Hello students, welcome you to this session. So far we studied a lot of integration, right? Definite integral, then properties of definite integral, then gamma integral, reduction formula, Bernoulli's formula, so many things we studied. So in addition to simple integration, we studied a lot of extra results. Now we are going to study some of the applications. A lot of applications there. So using integration, you can find area, volume, surface area, length, all these you can find. So in our syllabus, we have two applications. How to find area of a plane, okay, area, then how to find volume. Okay, these are things we have. So in today's class, I'm going to start first the basics, okay. So how to find area using integration. Okay, actually there are two types. One is area bounded by on x-axis. By that what we mean? See, x-axis, y-axis. Say a curve is given, curve is say y equal to fx. A curve is given, y equal to f of x. Then the ordinate at x equal to a and at x equal to b. So here you have a line at x equal to a, the ordinate, y coordinate, okay, and at x equal to b. Area bounded by all these four. So which four? The curve, x-axis, that is why we say area bounded on x-axis. So the curve y equal to fx, x-axis, and 2 points at x equal to a and b. This area, if I want to find this area, there is a formula. To find this area, area is equal to integral a to b y dx. Okay, a, b are the limits. Y you can find from the function, right? Integral a to b y dx. So this is area bounded on x-axis. Here one more thing I want to tell you. So in the lower class, in 10th standard, you would have studied how to find area of a triangle, right? So in coordinate geometry, suppose your answer is negative. So what we do, area cannot be negative, we make it as positive, that much square unit. So same way here also, if your answer is negative, you can't take it as negative, right? You take the positive value. To avoid that, if you have the diagram, there won't be any problem. So here the major thing is how to draw diagram and the portion, what they asked to find, which area they asked to find, that is more important. Then integration, by this time you would have been thorough with integration, right? If not, you cannot study this topic, right? So I am assuming you know integration. Now further, the application of integration. So here mainly I am going to teach you, if a statement is given, how to draw the diagram, which portion to be shaded, and what formula to use. Then integration part you have to do. I'll help you. Now and then few sums I'll help you. Okay. So I said there is one, to avoid the negative, I said you have to draw the diagram. So please listen. So it is y dx or it may be minus y dx. Depends on the portion. Lies, the shaded portion, the area lies above x-axis or below x-axis. If it is above x-axis, y dx, below x-axis, minus y dx. Then your answer will be positive. Suppose say this is x-axis, y-axis, and say this is the curve, and these are the 2 points. You want this portion, you want this area. It is bounded on x-axis only, but below x-axis. So when x-axis comes, you see whether it is above or below. Same formula, that y alone, if it is above, you write y dx. If it is below, you write minus y dx. Okay, so that you can avoid the negative sign. So this is one type, area bounded on x-axis. Then definitely the other one is what? Area bounded on y-axis, right? Area bounded on y-axis. That's the second one. Area bounded on y-axis. So here, say this is the curve, y equal to f of x. We take 2 points on y-axis, say a, y equal to a and y equal to b. Area bounded by the curve, the y-axis, and at x equal to a, and not x value, y equal to a and y equal to b. So this portion, if you want this portion, this one we call it as the area bounded on y-axis. Here the formula is integral a to b. There it is y dx, so here it is x dy. Area bounded on y-axis, area bounded on x-axis, the formula integral a to b y dx. So area bounded on y-axis, the formula integral a to b x dy. Okay. So here also, to avoid the negative sign, it is x dy or minus x dy. Depends on the position, right? In x-axis, we look into above or below. Above positive, below negative. In y-axis, we see whether it lies right side or left side. If it is right side, positive, x dy. If it is left side, you put negative, minus x dy. Okay, so that one thing you remember. And sometimes they give the curve. They won't give the limit. If the limit is not given for the first type, area bounded on x-axis, what is the specialty of x-axis? Y equals 0, right? If the limit is not given, you put y equal to 0. In the second case, that is bounded on y-axis. For on y-axis, if the limit is not given, area, you have to put what? X equal to 0 and find the limit, okay? Because y-axis, the equation is what? X equal to 0. And here some special cases I want to tell you. Using this method, you can find area in the first quadrant. You can find area in the first quadrant. Suppose when I draw the curve, suppose I am getting a loop like this. Above some portion, below also some portion. Okay. Then using this method, I can find this area. Area in the first quadrant. Integral a to b y dx. But like that, there is one more portion. So actual formula you write integral a to b y dx, you multiply by 2 because there are two portions, right? Suppose I want find area of a circle or area of ellipse. You know, there are 4 portions, right? Using this method, you can find area in the first quadrant, but there are 4 portions, so that answer you multiply by 4. Or sometimes you may get a double loop like this side one loop and here another one. So find this one like that, 4 portions. So you must know when to multiply by 4, when to multiply by 2, when not to multiply, right? So the usual method, you will get area in the first quadrant. And last, one more theory part I want to teach you. Area between two curves. Say this is one curve. So y equal to fx. Or I am taking y1 is equal to fx. And there is another curve. See this curve. y2 is equal to g of x. I want the area between the two curves. This portion I want. So what do you do now? You find the point of intersections. You find the point of intersection. Suppose at this point, say it is A and this is B. First, you find area bounded by the upper curve. Area bounded by the upper curve means you will get the full portion, right? Then you find area bounded by the lower curve. That is, you find only this portion. Subtract both. You will get the required portion. First, you find area bounded by the upper curve. Then you find area bounded by the lower curve. Area bounded by the upper curve means below this, the full portion you will get, right? From that, area bounded by the lower curve. So lower curve, it's below. This portion you remove, you will get the portion what we required. Okay, so what you are right to know. So upper curve, that y we have taken as y1. Lower curve, it is what? y2. So here the area is equal to integral a to b y1 minus y2 dx. So first you write upper curve because upper curve contains more area, right? So y1 minus y2 dx. That's all. If you are thorough with this one, you can do the sums very easily, but more important, you need integration, right? So you must know how to integrate and applying the limit, the calculation part. You have to be very, very careful, and almost all the questions, 5-mark questions only, okay? Okay, now let's start with the first question. Look at this question. Question will be like this, that's all. They won't give any diagram at all. Find the area of the region. Find the area of the region bounded by 3x minus 2y plus 6 equal to 0 at x equal to minus 3, x equal to 1 and x-axis. By seeing this, you can understand this is of which type, first type or second type? First type, bounded on x-axis, bounded on x-axis. So it is of the first type. And look at this one. By seeing this, you can understand this represent what? The curve. X degree 1, y degree 1. So it is a straight line. Suppose x degree 2, y degree 1. Or x degree 1, y degree 2, then it's a parabola, right? So here it is a straight line only. So we have to draw the line. Then only you can understand. So to draw a line you would have done in lower classes, maybe in 7th standard, right? You find at least 2-3 points, right? Minimum 2 points enough. See, what is the equation given here? 3x minus 2y plus 6 equals 0. I am finding y from here. Later, it is x-axis, so integral a to be y dx, right? Whether it is plus y or minus y, whether you have to multiply by 2 or 4, everything we decide. But before that, we find y from here. Take 2y to the right side. So 2y is equal to 3x plus 6. 2y is equal to 3x plus 6, or y equal to 3x plus 6 by 2. Okay, now we need some points, right? Minimum 2 points, x, y. Easy calculation for x, you put 0. If I put x equal to 0 here, first term fully 0, right? Y equal to 6 by 2. What is 6 by 2? 3. Second time you put y equals 0. So it is easy to plot on the x-axis and y-axis. Plot 2 points, join. That's all the line you will get, right? So put y equals 0. If I put y equals 0 here, if I put y equals 0, the second term 0, right? 3x second term 0 plus 6 equals 0, or 3x equal to minus 6. So x equal to minus 6 by 3. So minus 2. X value minus 2. Y equals 0. Please listen. This is very important. Most of the books, they won't explain this part, how to get the diagram. So this is more important. Once you get the diagram shaded, writing the formula, substitute, then you can do that, right? Calculation part. So this is more important. You have to understand properly. Okay. So now listen carefully. 2 points, you got it. So now with the help of these 2 points, we can draw a diagram. Okay. First, I just will draw a rough diagram. Then I'll show you the fair one. Okay. Just for you to understand. 0, 3. X-axis 0. Y-axis 3. Somewhere here, right? 0, 3. Then minus 2, 0. It is somewhere here. Minus 2, 0. Enough. That too you join, extend it. You will get a line, right? This is our x-axis. This is our y-axis. Okay, now listen. Which portion to be shaded? See, further they given x equal to minus 3. This is minus 2, minus 3 somewhere here. Minus 3 and x equal to 1. X equal to 1 is somewhere here. X equal to minus 3, this line. X equal to 1, this line. So the portion is this portion, also this portion. 2 portions are there, right? So you have to use y dx or minus y dx. Both we use. In x-axis, we have to see whether it lies above or below. Some portion lies above, some portion lies below. Which portion from which point to which point? Minus 3 to minus 2, it lies below. Minus 2 to 1, it lies above. So area you find in 2 parts. Integral a to b y dx. If you get some point in the middle, a to c plus c to b, you can write some of the properties there, right? Actually from minus 3 to 1. If entire portion lies above, in a single integral, minus 3 to 1 y dx. If the entire portion is below, minus 3 to 1 minus y dx. But some portion lies below x-axis and some portion lies above x-axis. So where it changes? At minus 2. So that is the break point, right? Minus 3 to minus 2, then minus 2 to 1. Minus 3 to minus 2 lies below, so minus y dx. And minus 2 to 1, it lies above, so y dx. Okay, hope you understood. Now I show you the fair diagram. Okay, this is the diagram you have to use. Okay. So now the required area is equal to minus 3 to minus 2. Minus 3 to minus 2 minus y dx plus minus 2 to 1 y dx. Hope you understood this properly. Now it's very simple, students. Just you substitute the value of y. This is our y value, right? 3x plus 6 by 2. 3x plus 6 by 2. Okay, now please listen. So this is equal to integral minus 3 to minus 2. That minus I am writing outside. Or you know another one, no? The property can use minus. Why are you taking this minus along with us, right? That minus you adjust with the limit. You can interchange the limit. You will get a minus. That minus become plus. That's good, right? So we do like this. So instead of minus 3 to minus 2, I am writing minus 2 to minus 3. Now it is only y dx. Plus integral minus 2 to 1 y dx. So see the situation and you can do that, okay? So that is integral minus 2 to minus 3 y. What is y value? 3x plus 6. 3x plus 6 by 2. 3x plus 6 by 2. That by 2 I am writing outside of dx. Plus integral minus 2 to 1 y value 3x plus 6 by 2, that is 1 by 2 dx. Now you have to integrate and apply the limit, okay? This is the first sum, no, so I will do the full calculation. Okay, listen. 1 by 2 into 3 into x integration x square by 2 plus 6 integration 6x limit minus 2 to minus 3 plus 1 by 2 into 3 into again x integration x square by 2 plus 6 integration 6x limit minus 2 to 1. So you see that is 1 by 2 into, first you give the upper limit. So 3 by 2 is already there. 3 by 2 into x square minus 3 square 9 plus 6 into minus 3. 6 into minus 3. So minus 6 3s are 18. So this is the upper limit. Now minus lower limit 3 by 2 into, you are giving minus 2. Minus 2 square 4. Then 6 into minus 2, it is what? Minus 12. Only the one term is over. Plus 1 by 2 into, now again upper limit is 1. So 3 by 2 into 1 square is 1 plus 6 into 1 is 6. Minus lower limit minus 2. So 3 by 2 into minus 2 square 4. Plus 6 into minus 2, it is minus 12. Okay, now please listen. So what you can do here, 1 by 2 is common in both the terms, right? 1 by 2 into, listen, first one, 9 3s are 27 by 2, then minus 18, right? Minus 18. Here you cancel 2 table, 2, what you're getting, 3 2s are 6. 6 minus 12, minus 6 outside minus 6 is what? Plus 6, right? So calculations up to you. So just I'm showing one example, that's all. Now plus, here 3 by 2 plus 6. Here 2 table you cancel 2, so minus 6, right? Minus 6. Or you can simplify that and write, okay? So here actually 6 minus 12. 6 minus 12 is minus 6. Outside a minus is plus 6, right? Now listen, these two you simplify. Both denominators are 2, right? 1 by 2 into 27 by 2, 3 by 2. 27 plus 3, 30, right? So 30 by 2. Then you see, please listen here, positive values 6 plus 6 plus 6. 6 3s are 18 and minus 18 cancel, right? Only this much you are getting. So cancel by 2 table, 15. Outside a 2 is there. So your answer is 15 by 2. Area you are finding. So just you write square units. Okay, hope you understood this one. Now let's move on to the next question. Look at the next question. Find the area of the region bounded by. Similar question only, but I want to explain to you how to draw the diagram, which portion to be shaded, what formula to use, whether plus or minus, then substitute. Then integration part, I am going to leave it to you. Okay, so that you have to practice. Find the area of the region. Please listen. See the given curve. 2x minus y plus 1 equal to 0. X degree 1, y degree 1. You know it is a straight line. Y equal to minus 1, y equal to 3 about y axis. So second type, integral a to b x dy, right? Whether it is plus x or minus x, we will see. Limit minus 1 to 3. Y varies from minus 1 to 3. It is a straight line. So first you draw the line. For that you need 2 points, right? So here formula x dy. So let us find x from here. 2x is equal to minus y, take that side, plus y minus 1. So x is equal to y minus 1 by 2. Okay, now minimum 2 points you find out, okay? Suppose if you get some fraction, you take some other point, xy. Suppose I take x equal to 0. X equals 0 means in the given function you put x equals 0. When I put x equals 0, the first term is 0. Minus y plus 1 equal to 0. I am giving x equals 0, right? So minus y, take that side, plus y equal to 1. So 0, comma 1, that is 1 point. Now if I put y equal to 0, what happens, you know? If I put y equal to 0, y equal to 0 means x equal to minus 1 by 2, right? You can plot minus 1 by 2, 0, minus 1 in between, right? Or you give some other number. Say I am giving y equal to 3. If I put y equal to 3, 3 minus 1, 3 minus 1 is 2. So 2 by 2 is 1. So x value 1. Even that 2 points enough, right? So we draw a rough diagram. Please listen. So 0, 1, right? X-axis 0, y value 1. 0, 1. 1, 3. X value 1, y value 3. It may be somewhere here. Okay. So these 2 points join and extend it. Okay, it is 3. Now, from where to where? Minus 1, 2, right? So we want from minus 1. Which value? Y equal to minus 1. Y equal to minus 1 is somewhere here. Y equal to minus 1 and y equal to 3. 1, 2, 3. It is somewhere here. Y equal to 3. Y equal to not x equal to previous one. X equal to. Here y equal to 3 and y equal to minus 1. So this one. So the portion to be shaded is this portion and this portion. Actually y value from minus 1 to 3. Minus 1 to 3 x dy. Plus x or minus x. If it is, since it is y-axis, you have to see whether right side or left side. For right side positive, left side negative. Here partly right side, partly left side, right? So minus 1 to 1. Minus 1 to 1 it is left side. So minus x dy. But 1 to 3 it is in the right side. So x dy. Hope you understood this, right? So this is the fair diagram. So required area is equal to integral minus 1 to 1. Minus 1 to 1. Since it is y-axis, bounded on y-axis, so x dy. So it's left side, so minus x dy. Plus 1 to 3. It is right side, so x dy. Now x value already got it, right? That's the reason we are finding x value. X equal to y minus 1 by 2. X equal to y minus 1 by 2. Now please listen here. The first one, as I said earlier, minus you can adjust with the limit. R minus, here y minus 1, the previous question term both positive. So we cannot change this. Here y minus 1, you can write it as 1 minus y. Like that also you can do, right? Okay, anyhow, I am changing the limit, okay? Instead of minus 1 to 1, I am writing 1 to minus 1 x dy. What is x value? Y minus 1 by 2. That by 2 I am writing outside of dy. Plus integral 1 to 3 x dy. X value y minus 1 by 2. That is 1 by 2 dy, right? We have to do the integration, simple integration. Listen. So 1 by 2 into y integration, y square by 2 minus 1 integration. We normally write x if it is dx. Here it is dy, so 1 integration is y. Plus 1 by 2 into y integration y square by 2 minus 1 integration is y limit 1 to 3. In both the cases 1 by 2 is common, right? If you want you can take that 1 by 2 outside. First you give the upper limit minus 1. Minus 1 square 1 by 2 minus minus 1, so plus 1. Minus. You give 1 now, 1 square is 1 by 2 minus 1, right? So this is the first one. Now plus 1 by 2 already taken out. Now we give substitute 3. So 3 square 9 by 2 minus 3 minus. Now we give 1. 1 square is 1 by 2 minus 1, right? So that is 1 by 2 into. So I'm not going to simplify now. 1 by 2 plus 1 minus 1 by 2 minus minus is plus 1. Plus 9 by 2 minus 3 minus 1 by 2 minus minus is plus 1. Whatever you cancel, right? 1 by 2 into. Calculation is up to you. Don't need to follow what method I am doing, right? Which one you find comfortable, you do that. But you have to practice it. Don't say, I know the method, I understand the diagram and all. In the exam hall, I will do the calculation. You won't do that. In the half, it will stack up. So you need proper practice, okay? So here you can cancel 1 by 2 minus 1 by 2, right? Anything else? That's all I think, right? Now the positive denominator 2, that 2 we add. 9 by 2 minus 1 by 2. So 8 by 2. Now the constants you see 1 plus 1, 2 plus 1, 3 minus 3 cancel. Okay, good. So that is 2 table you cancel, right? You are getting 4. Again this 2 cancel, you are getting 2. So your answer is 2 square units, right? Okay, hope you understood. Mainly read the question, try to draw the diagram. Okay. Okay, now let's move on to the third question. Find the area of the region bounded by the curve 2 plus x minus x square plus y equal to 0. This represents what? See, x degree 2, y degree 1. So it is a parabola, right? On x-axis. So first type integral a to b y dx. So I am keeping y alone here. Y equal to, take all the terms to the right side, minus x square, take that side, plus x square, plus x minus 2. So this is a given curve, y equal to x square type, right? X square. So it will be a parabola, x degree 2, y degree 1, x square equal to 4ay, open upward or open downward, right? So x square equal to 4ay type, so it will be open upward. So where it cuts x-axis, a rough diagram we need. So what I'm going to do, we simplify, we try to factorize the right side. So y equal to, sum is minus 1, product is minus 2. The numbers are minus 2 and 1. Coefficient is 1, so straight away you write x minus 2 into x plus 1. X minus 2 into x plus 1, right? So y equal to 0 means x minus 2 into x plus 1, 0, right? X minus 2 into x plus 1, 0. Either x minus 2, 0 or x equal to 2 and x equal to minus 1. So you are getting a rough diagram. It is an open upward parabola, x equal to 2, x equal to 2 and x equal to minus 1. It cuts at these 2 points, okay? Minus 1 and 2. Now you see here x equal to minus 3 and x equal to 3. X equal to minus 3, minus 2, minus 3. Somewhere here x equal to minus 3 and x equal to 3. 2 after 2 it is 3. So area bounded by these two lines, that is this portion and this portion. All these three will come. So this minus 3 and plus 3 in between the entire portion. So it is x-axis, so we have to see above or below. In two places it is above, right? In that two places you put y dx and this below, there you put what? Minus y dx. So this is minus, so minus 3 to minus 1, minus 1 to 2, 2 to 3, right? Minus 3 to minus 1 y dx because above x-axis. Minus 1 to 2 minus y dx below x-axis. Then 2 to 3 again above, so y dx, okay? So this is a fair diagram. And what is y value you are getting here? Y equal to x square minus x minus 2. Y equal to x square minus x minus 2. Okay, so the points, this is minus 3 and this is plus 3. So the required area is equal to integral minus 3 to minus 1 y dx, that is above, plus integral minus 1 to 2 minus y dx, plus integral 2 to 3, that 2 to 3 that is again above, right, y dx. Now you know how to substitute, simplify everything. First one y, instead of y you write this one. Integral minus 3 to minus 1 y dx, what is that? X square minus x minus 2 dx. Here minus y, that minus either you put outside or you put plus, interchange the limit, 2 to minus 1 you write. Instead of minus 1 to 2 you write 2 to minus 1, again y only. So x square minus x minus 2 dx. And the last one is plus 2 to 3, integral 2 to 3, again y only, x square minus x minus 2 dx. Integration is a very simple integration only, but applying the limit and the calculation part you do very carefully. Take a rough paper and write again and again 2-3 times, then only you'll get the confidence. Okay, x square integration x cube by 3 minus x integration x square by 2 minus 2 integration 2x. Limit minus 3 to minus 1. Plus next one you write the same thing only, no? You write and the limit 2 to minus 1 and the last one same integration only but limit 2 to 3. Okay, all the three parts you simplify and check what answer you are getting. Check whether you are getting. So I want you to try to complete our solve. Okay, so if you find difficult here, that means you need more help in integration and calculation. Integration you may know, but calculation part, taking LCM plus minus, practice well. Okay. Now let's move on to the fourth question. Listen carefully, sum number 4. Find the area of the region bounded by the line and a parabola. A line and parabola. So please listen. This is a parabola. So let us see how the diagram will be. Y equal to x square type, right? So open upward, previous one. So where it cuts x-axis, y equal to take x, okay, x square minus 2x. So y equal to take x outside, you are getting x minus 2. Y equal to 0 means x equal to 0 and x equal to 2, right? X equal to 0 and x equal to 2. So it cuts at that 2 points, right? 0 and 2. Okay, so parabola. Now a line is there, no? So instead of drawing the line, you find the point of intersection of these two. So both left sides are same. So the right sides are equal. See, y equal to x square minus 2x. Another one y equal to 2x plus 5. The point of intersection where these two meet, that point only we need. So left sides are equal, so the right sides are equal. X square minus 2x equal to 2x plus 5. Bring everything left side. X square minus 2x minus 2x minus 4x minus 5 equal to 0, which can be factorized. X minus 5 into x plus 1 equal to 0, x equal to 5 and minus 1. X equal to 5, it is somewhere here, right? X equal to 5, this point. X equal to minus 1 is somewhere here, this point. At these 2 points, the line and the curve intersect, okay? So at these 2 points, so the diagram, the line will be like this. So we want the portion between the parabola and the line. So that means this is the portion we want. We want the portion between. So this is area between 2 curves. Area between 2 curves, the method I taught, right? Area bounded by the upper curve minus area bounded by the lower curve. What is the limit here? Minus 1 to 5, right? Minus 1 to 5. So x varies from minus 1 to 5. Upper curve means the line. So what is lines? Y 2x plus 5. Lower curve means the parabola. What is y value there? Y equal to x square minus 2x. Okay. So the required area is equal to integral a to b y1 minus y2 of dx. That is integral minus 1 to 5 y1. y1 is from the line y value 2x plus 5, right? That is y value. From the curve, the y value is what? The curve y value is y equal to x square minus 2x. That's what given there. Upper curve means the line. You can see the diagram, right? Curve is there. In the top, the line is there. The shaded portion you see. In the shaded portion, the above what is there? Line is there. So y1 means 2x plus 5. 2x plus 5. Minus of y2. What is y2? The y from the lower curve. Lower curve means the parabola. X square minus 2x. X square minus 2x of dx. Now we can simplify. That is integral minus 1 to 5. 2x plus 5 minus x square minus minus plus 2x of dx. So you are getting, simplify, minus x square, or you write some positive value, right? 2x plus 2x, it is 4x, plus 5 minus x square, right? Integral minus 1 to 5 of dx. Now we integrate it. 4 into x integration x square by 2 plus 5 integration 5x minus x square integration x cube by 3. What's the limit you apply? Minus 1 to 5. So now we can do that. No? So for the 2 and 4 you cancel, you are getting 2. First, wherever x comes, you put upper limit. What is upper limit here? 5. So 2 into 5 square. What is 5 square? 25. 25 into 2, 50. Plus 5 5s are 25. Minus 5 cube, 125 by 3. Minus, now we give the lower limit, minus 1 square. Minus 1 square is 1. 1 into 2, it is 2. 5 into minus 1, minus 5. Minus 1 cube is minus 1. So minus into minus is plus 1 by 3. So you simplify these two, you are getting 75. Minus 125 by 3. Here these two together minus 3, outside minus. So it is plus 3 and minus 1 by 3. So these two together 78, right? 78 minus, simplify these two by 3 is there, 126, right? So 78 minus, cancel by 3 table, 42, right? So 78, 42, if you cancel, what you are getting, 36, right? Okay, so calculation part, don't be afraid, no other way, no other substitute for hard work, right? You have to do that. The previous question, of course, it will end the only, like here I did one part, right? Like this, there are actually 3 parts. So 3 values you will get, you had to add everything, okay? But you practice it. Okay, now just to explain one more question, that's another very important question. Listen, find the area of the region bounded between the curves y equal to sin x, y equal to cos x. So you must know sine curve and cosine curve. Please listen. For sine and cos, values lies between 0 and 1. Maximum value 1, minimum value minus 1. Here between 0 and pi only. So 0, then I'm marking 0, 90, 180. Then it goes on like this, right? Sine curve, you know. What is sine 0? 0. Sine 90 is 1. This one, then here 0, sine pi is 0, then minus 1, right? If I draw sine curve, the curve will be like this. This is sine curve, okay? It goes on like this. Left side also it will be in this side, it goes. But cos curve, cosine curve, cos 0 is 1, it starts from here. Cos 0 is 1, cos 90 is 0, cos pi is minus 1. So the curve will be like this, cosine curve. Okay, it goes on like this. So this is y equal to sin x. The red one, it is y equal to sin x. Okay, this is y equal to sin x. And the other one, this one, say y equal to cos x. So we want to find the area between these two. Area between the two curves means this portion. Don't take this. This is not the area between the two curves bounded on x-axis, right? That they didn't ask. Area between the two curves, this portion, but up to pi only they ask, right? At pi you draw a line, so only up to pi, not this portion. This portion we don't want, okay? So this is the diagram. Hope you got some idea, right? So this is what we need. So we have to, at this point, some break, right? So we have to find the point of intersection. For that, one curve is, listen, the red one, that is y equal to sin x. So this is y equal to sin x. And this green, that is y equal to cos x. Okay, now I want this point. So there is some break, right? So here the red curve is below. But after that the red curve goes up, right? So upper curve, lower curve changes the position at this point. So I want to find, this is the meeting point of the two curves. What are the two equations? Y equal to sin x. Another one y equal to cos x. I want to find the point of intersection. Both left sides are same. So you can say the right sides are equal. Sin x equal to cos x. Sin and cos are equal when x equal to 45. In the table you know, no? The 0, 30, 45, 60, 90, sin, cos, same value. 1 by root 2, 1 by root 2 for 45. So theta is equal to x equal to 45, pi by 4. Or you do, if you want, write the step. Divide both sides by cos x, or bring that cos x to the denominator here, left side. So sin x by cos x equal to 1. Sin x by cos x means tan x is 1. Tan x equal to 1, so x equal to pi by 4. So this point is pi by 4. So 0 to pi by 4, then pi by 4 to pi. So we don't want fully, sorry, here I marked fully, right? So don't shade up till the end. We want only up to what? Pi. Only up to pi. In the question they specified, okay? They specified 0, x equal to 0 and x equal to pi. X equal to 0 is this line and x equal to pi is this line, okay? This is pi, okay, not up to. So 0 to pi by 4, pi by 4 to pi. 0 to pi by 4, required area equal to, listen very carefully, integral 0 to pi by 4. Upper curve minus lower curve. Please listen. Up to 0 to pi by 4, what I shaded first? Which is upper curve? The green. Lower curve is red. Don't write green minus red. The green curve represents what? Cos x. For you to identify only like given. For the examination, don't use multicolor and all. You have to use only pencil scale only. Okay. So, and you name it, the upper curve. So, in that area, the upper curve is cos x, lower curve is sin x. So, you write upper curve minus lower curve. So, cos x minus sin x. Cos x minus sin x dx. Plus integral pi by 4 to pi. Now the second region, what we shaded second, pi by 4 to pi. Now which is the upper curve? The red goes up now. So that is sin x. And the green comes down now. That is a lower curve now, right? Upper curve minus lower curve means now it is sin x minus cos x. So sin x minus cos x dx. Hope you understood. The remaining just integration, very simple, right? Cos x integration, sin x, right? Cos x integration, sin x. And sin x integration minus cos x minus minus is plus cos x. Limit 0 to pi by 4. Plus sin x integration minus cos x minus cos x integration sin x. Limit pi by 4 to pi. Apply the limit now. First you are giving pi by 4. Sin pi by 4, 1 by root 2 plus cos pi by 4, 1 by root 2. Minus, you give 0 now, sin 0 is 0, cos 0 is 1. Now, from the next 2, if you want, you can take a minus sign outside, no need, okay, let it be. Plus, upper curve pi, cos pi is minus 1, minus minus 1 is plus 1, minus sin pi is 0. Put a minus sign. Now, we give pi by 4, 45, so minus cos 45, 1 by root 2, minus sin 45, 1 by root 2, right? That's all. Now, do the simplification. 1 by root 2 plus 1 by root 2, 2 times 1 by root 2, minus 1. Here plus 1, minus. Here minus 1 by root 2, minus 1 by root 2 means minus 2 times 1 by root 2, right? That minus into minus is plus 2 times 1 by root 2. Minus 1 plus 1 cancel. 2 times 1 by root 2 plus 2 times 1 by root 2, totally 4 times 1 by root 2. Okay, calculation I said you do in any way. Okay, what I am doing in the way what I know, right? Okay, now 4 by root 2 multiply by root 2 by root 2, right? So 4 root 2 by 2, cancel 2 table. So what's your final answer? 2 root 2 square units. Okay, students, hope you understood all these things. You should not have any doubt in drawing the diagrams and shading the formula. That is much more important, this topic. The remaining up to your hard work. We'll continue next class.